Hi everybody, welcome back to another video lecture from Mrs. Semino. If you look at this worksheet, you're going to see that it's about 3 pages. I think I'll probably end up making 3 separate videos for one for each page, just so that the videos can be a little bit shorter. Okay, so you've already watched the introduction to a mole's how big is a mole video. So hopefully you guys remember that a mole is just a way that we measure things in chemistry or science in general. Atoms are really, really small, right? We can't see them. So the quantity that we can measure is really, really big because those atoms are so small. So the first thing we want to look at here are these definitions of a mole, representative particle, and molar mass. These are definitely words that you're going to see over and over again. So to start off with, you guys, a mole is a word that represents 6.02 times 10 to the 23rd things. We're mostly going to be talking about representative particles in class, but like the video said, you could have a mole of donuts that covered the planet almost like 1.5 kilometers deep, or a mole of basketballs that would be the same size of Earth. So whenever we say we have a mole of something, it means we have 6.02 times 10 to the 23rd. Now, a representative particle is a generic term, and so if I say we have representative particles, it could mean that we have atoms, ions, formula units, or molecules. So right now we've been talking a lot about atoms, right? They're neutral, they don't have a charge. Ions are atoms that do have a charge. But for this one here, formula unit, this might be a new term, but anytime we see NaCl, that's the smallest way that we would write sodium chloride. So remember, this is going to come from ionic compounds. And then a molecule is going to come from, shockingly, molecular compounds, or the ones that we've talked about that have covalent bonds. So ionic compounds have ionic bonds, molecular compounds have covalent bonds, and we describe them as being molecular. So anyways, a representative particle can mean any of these 4 things. It's a generic term. It's like if I said, hey, people can mean boys, girls, other. And then finally here, the definition for molar mass is that it's the mass of 1 mole of a substance, and we measure this in grams. Now there's a couple of conversion factors here that we're definitely going to need to use. So make sure that you guys write these down, and ideally you're going to memorize them because it's going to make your life so much easier. So the first conversion factor that we're going to look at is that 6.02 times 10 to the 23rd equals 1 mole. And notice here how it says RP. So that's just my abbreviation for representative particles. So you could have 6.02 times 10 to the 23rd atoms, 6.02 times 10 to the 23rd ions, formula units, molecules. Hopefully you guys are seeing that. And then the second conversion we have is that 1 mole equals the molar mass. Now, one thing that we're going to see, so if we had 6.02 times 10 to the 23rd atoms, it's going to weigh this specific amount, and this is one of the things that we're going to learn today. And then finally, this one we don't use as often, but this is more about volume. So if 1 mole is equal to 22.4 liters, and we might have seen that in the video before. So I just want to kind of backtrack here. So this is talking about the representative particles. So 1 mole representative particles. So this is talking about that 1 mole is equal to 6.02 representative particles. This is talking about mass. So if you see the problem, ask about mass. And down here, this would be volume that they would be asking for in the problem. So the next thing that I'm going to talk about is how do you actually calculate that value, or that thing called the molar mass. So that's what I'm going to show you here. Remember, always when I do my problems, I'm really wanting you, maybe the first 2, you just watch the video and follow along. But then after that, try to do them on your own, and then go back and unpush the pause button, push play, and then check your answers. Sorry, it's early in the morning again as I'm making this video. Okay, so what we would do here, so now we can see that we have bromine gas and we need to find the molar mass of bromine gas. What we're going to do is we're going to write Br, and remember we just like the symbols, and then hopefully you guys can see that little subscript there, the 2, so we know that there's 2 bromines. So what I'm going to do now is I'm going to look on the periodic table and I'm going to figure out what the molar mass is of bromine. And when I write my molar mass, notice that I go out to 2 decimal places. So sometimes you might need to round to get to 2 decimal places, so make sure you're doing that. But you're just going to look off the periodic table. This is the average atomic mass, and so when we just go 2 times 79.90, hopefully you're going to get 59.80, and then it's molar mass, so it's going to be in grams. Okay. The next one is water. I didn't give you the formula here, so hopefully you know water is H2O. So we're going to set this up pretty similar. We're going to go hydrogen. We've got oxygen, so we identify our elements. We write them down. Then we look to see how many atoms of each element we have. Hopefully you guys are like, okay, we've got 2 of hydrogen and we have 1 of oxygen. Now we're going to look on the periodic table, and I'm going to look to see what the mass of hydrogen is. And it looks like it's 1.01. Notice that I'm rounding there, right? So we can have the 2 decimal places in our molar mass. And then this one is a little tricky. We're definitely rounding for this one because this is like 15.999, so that rounds up to 16. So what you're going to do is you're just going to go ahead and do the little math here. Since there's 2 different elements, we need to add up the mass of the 2 different ones. And then, so when I add this up, it's going to be 18.02 grams. And you probably remember seeing that from the video. And if we have like a messy thing going on our page, I'm going to love it if you guys can like box your answers for these. Okay, so let's look at bleach here. So this is sodium hypochlorite, chlorite, sorry. And so you guys have probably, heard of bleach before, and then this is the active ingredient in there. So if we wanted to find the molar mass for bleach, we're going to take our sodium atom. We can see that we have chlorine, and then we also have an oxygen atom. So how many of each atom do we have? Remember, pause the video, try this one on your own. Okay, so you've got 1 sodium, 1 chlorine, and then 1 oxygen. So if you look on the periodic table for this, again, we're doing some rounding here for sodium, right? So we can get those 2 decimal places in. We look at chlorine, and it's going to be 35.45. We look at oxygen, it's 16 again. So we go ahead and you can rewrite it. I'll rewrite it so you guys can see, but sometimes as we keep going, you're going to see I kind of make some shortcuts in my writing. So if we add all this up, hopefully you're going to say that it's 74.45 grams. I'm going to move the slide up a little bit and then box my final answer. Okay, so you guys, here's sucrose. Try this one on your own for number 4. Pause the video, and then when you're ready, come back. I'm still here. Okay, so you guys, the way that this is going to work is we're going to take our carbon, we're going to take our hydrogen, we're going to take our oxygen, we're going to figure out how many atoms of each do we have. Hopefully you're seeing that there's 12 carbons. Whew, a lot of hydrogens there, and then 11 oxygens. So what we're going to do is we're going to look these values up on the periodic table, go out to the hundredths place when we write them. So carbon's 12.01. Again, hydrogen is 1.01, and then oxygen is 16.00. So we got to do some math on this, okay? So this is what I mean by I'm going to kind of shorthand this. So then I'm just going to do some math, and then this is all going to add up to 342.34 grams. Just, you don't have to write this. If I saw all this work over here, like, so I know where all these numbers are coming, you don't have to like write this out for right now. Ooh, I just looked, we're at 9 minutes for this video already. So I'm just gonna go ahead and give you the answers for a couple more over here. So octane should have a value of 108.20 grams. Silver chloride should be 143.32. So remember guys, you can't just write your answer over here. You have to show me all of this work. in order to get credit for this, but I just want you to be able to check your answers over here. And then I would say, check the answer key when you get in class for these. Thanks, guys.